Welcome to the design video for the University of South Australia Car 16 Formula FSAE-A Competition 2018. I'm Scott Evans, the President of the Motorsport Club, and I've got with me today Josh Cade, the Mechanical Engineering Manager for the team. For 2018, our core goals were to have a simple, drivable and reliable car that's cost effective to purchase and maintain and enjoyable and robust to own. The design focus was achieved through a tubular space frame chassis that's efficient to manufacture and build, a common motorcycle single cylinder 450cc motor, robust vehicle dynamics, batch production and common components and materials for manufacture. The specifications of the car are a 0 to 100 time of about 3.5 seconds, over 2G of lateral acceleration, and approximately a weight of 220 kilograms, which means we need about 50 horsepower to achieve those goals. The main features of the car will be a great steering feel and excellent drivability, high mechanical grip levels, and the best bang for buck in this category of vehicle. Easy to use and manufacture is another really good feature. To go into the specific details of this, I'll pass to Josh now for an engineering perspective.
Cheers. First goal of drivability was achieved by reducing steering torque, which was accomplished by reducing mechanical trail, increasing the scrub radius and decreasing the tyre width. We also implemented a consistent and tunable suspension platform using an unequal length independent suspension front and rear. We also included 1-to-1 linear ratio damper actuation in order to ease tuning. From initial testing, we found that our vehicle dynamics were lacking for implementation of an aero package. Therefore, using that data and a risk matrix, we decided to spend the time that we would have spent developing aero on developing our vehicle dynamics understanding and tuning capabilities. We've done this by the use of lap time, telemetry, and driver feedback. Our next goal was reliability. For this, we have implemented the simple 450cc motor, as mentioned by Scott. This is a cheap, easy to tune and reliable motor. One downside though is that it's a single producing harmful frequencies, and for this we've implemented soft mounts this year in order to isolate the rest of the car from these frequencies, increasing the fatigue life of components. We've also redesigned our intake in order to optimize the flow and better make use of a plenum. We've also made it out of aluminium this year instead of 3D printed plastic in order to increase its lifespan. We've also redeveloped our fuel system in order to take better note of pressures and heat sources within the system. And finally, we've redeveloped ducting for our cooling system in order to optimize the amount of air being used and make better use of the drag being created by the car. On to Scott to talk about the manufacturability.
Thanks, Josh. A big focus of the team was manufacturability and being able to scale production for the designers and builders of this car. So some of the ways we achieved that, one good example is the suspension component. We were able to take laser cutting designs of all of our suspension components, get them manufactured externally, and then bring them in and easily and cheaply weld them in a Jeep to produce reliable and robust components, thus increasing the scalability of the car and reducing the cost. Another way that we increased the scalability and the design of the car was the 3D printing of design iterations. So we were able to design and print many iterations so that we could test fit them in the real world quickly and efficiently, and test that the assembly and the manufacturability was as we had designed. This was a great way to quickly and efficiently go through a bunch of iterations of design and test that they were performing as we wished. So that closes out our design video for the year. Thank you very much, Josh.
Thank you, Scott.
And thank you for watching.